Hello everyone. In this video I am going to work through the Algebra II 8.4 through 8.6 practice quiz. So the first problem says to rewrite in exponential form. So remember we always have this as our base. So this is 5 and then our exponent is 2 and then that equals 25. And that's it. And you should always check to make sure your answer is something that is actually true. In this case, we know 5 squared is 25, so that works. All right, and number 2, same idea. 7 is our base. The part on the other side of the equal sign is our exponent, and then that equals y. So we just end up with an equation here. Can't really check that one, but that is the right answer. Okay, now we're going to go backwards and rewrite this in log form. So we have log, our base is 8, the other number comes next, and then it equals your exponent. All right, and then lastly, we have log, our base is 3, next we have 21, and then that equals your exponent. All right, so there are the first 4 answers. Okay, so let's move on here. In number 5, they want us to find the inverse of the function. So remember your first step always is to switch x and y. So we're going to say x equals log base 2 of y minus 1. And then the next step is to change form. So since this is a log, we're going to change it to exponential form. So 2 is our base, x is our exponent, and then that equals the thing in the log, which is y minus 1. And our last step then is to get y by itself. So I'm going to go ahead and add this 1 over. So we end up with an answer of 2 to the power of x plus 1 is equal to y. And I always just like to rewrite that as y equals 2x. 2 to the power of x plus 1. Okay. Number 6 is just a little fill in the blank problem here. So remember the common log. So if you just see log without a base, we assume that the base is 10. And then the natural log, ln, always has a base of e. Okay. Next problem is going to get into some graphing here. So we're going to graph this log function. So first thing I always like to do is just put a box around the parent function, and then we're going to do some shifting. So remember, in order to graph logs, we actually switch it into an exponential. So this is going to be 2 to the power of y is equal to x. And that's why we plug in for our y values in our table. So I'm going to use that fav5, but I'm filling those into the y. So like we're going to do 2 to the power of negative 2. That's going to give me my first x value, which is a fourth, or 0.25. This is 2 to the negative 1, which is a half, or 0.5. And you're more than welcome to plug these in the calculator if you're not sure what they equal. 2 to the power of 0 is 1, 2 to the power of 1 is 2, and 2 to the power of 2 is 4. Okay, so let's go ahead and graph those for our 5 points. So we go over 0.25 down 2 is the first point, over a half down 1, over 1 up 0, over 2 up 1, and over 4 up 2. And I'm going to make a dashed line through these because remember, this is my parent function. This isn't quite my final answer yet because I still need to apply this shift. So this right here inside the parentheses means we're going to move all those points left 3. And then this minus 4 out here means we're going to move them down 4. So let's go ahead and take the points and move them. So this first point left 3 and down 4. 1, 2, 3, 1, 2, 3, 4 ends up being right there. Okay, so left 1, 2, 3, down 4. Left 1, 2, 3, down 1, 2, 3, 4. left 3, down 4, and left 3, down 4. So we are going to get some overlap here, that's okay. So this line here is going to go straight down, and then as we go to the right, it's going to kind of keep going up and up forever. All right, and then we've got a couple of questions to answer here. So the vertical asymptote is this line here where it starts to go straight up and down. So it's this line here. And a couple of ways to just know that it's this line where your graph starts to go straight down. And it's also based on your horizontal shift. So that +3 kind of gives you the equation. So it's going to be this line, x equals -3. Is the equation for our vertical asymptote. The domain is based on that number. Notice since our graph is going this way, so it's going to the right of that line, we would say x is greater than 3. And that's because our graph over here is pointing to the right. And then lastly, the range, we can plug anything in for y, so that is all real numbers. All right, so that's the graphing of log functions. Okay, we're going to do a couple of expanding problems. So in this one, your final answer should only have one thing after each log. So first of all, this is 5 times x squared. So I'm going to split this log into log base 7 of 5. Remember, multiplication expands into addition, so we're going to say plus log base 7 of x squared. Then we can go ahead and plop down this power. And we would say log base 7 of 5 plus 2 log base 7 of x. And now since we only have a 5 after the first log and an x after the second log, this is completely expanded. Okay, let's try another one here. First, we're going to split up this division. Remember, division splits the log into subtraction. So we've got log base 3 of 7x squared minus log base 3 of y. And then we can split up this first log because this is multiplication. So this can split into log base 3 of 7 plus log base 3 of x squared, and then we still have this minus log base 3 of y. And then lastly, our exponent can come down in front of that middle log. So our final answer is going to be log base 3 of 7 plus 2 log base 3 of x minus log base 3 of y. And the first log just has a 7 after it, next one just an x, and the next one just a y, so that is as expanded as it can get. All right, now in 10 and 11, we're going to go backwards. We're going to condense these into a single log. First step is always to bring back and restore any exponents that are in front of a log. So that's our first step in number 10. This is going to turn to log of 6 squared minus log of 3 squared. And then since we have subtraction right here, we can turn that into a fraction. So this is log of 6 squared over 3 squared. And since these are numbers and we can do the math pretty easily here, we should do that. So this is log of 6 squared is 36, 3 squared is 9, and we know 36 divided by 9 is 4. So all of that just turns into log of 4. Okay, let's try another one. So number 11, we have 3 logs. Since there's parentheses around this first set, we can actually combine these. So we can do this as log. Remember, addition goes with multiplication, so this is going to be log of 5 times 4. Here I can restore this exponent in the back log. So this is log of x squared. Okay, and then we can turn this into a fraction because of the subtraction. So we got log of 5 times 4 is just 20, so that's going to be in the numerator, over x squared. And I don't think there's anything else we can do. We got 1 log, so that is our final answer. Okay, and then our last set of problems are where we're going to solve the following equations. So if you just have a log on one side of the equation, which is the case in number 12, always a good rule of thumb is if you're stuck, try changing the form. So we're going to change this into exponential form. But before we can change form, we have to get the log all by itself. So we're going to go ahead and divide both sides by 5 to get rid of that 5 right here. So these will cancel. And we end up with log base 2 of x equals 3. Now that the log is all by itself, we can change the form. So 2 to the power of 3 is equal to x. And we know 2 cubed is 8. So 8 is our x. All right, we're going to do a pretty similar process in number 13. We're going to have to get this e to the x all by itself first. So let's subtract 20. And then these will cancel. We end up with 4e to the x equals 180. And then if we divide 180 by 4, we get 45. So e to the x equals 45. And now we can go ahead and change the form. So this is log base e of 45 is equal to x. Now you should recognize this. Remember back here in problem number 6, we said the natural log has a base of e. Well, that's what we got going on right here in number 13. So we're going to replace that with the natural log of 45 is equal to x. Go ahead and grab your calculator, plug in ln 45, and we get about 3.8066664. So I'm going to say this is 7. All right, so there's our answer. Okay, and 14 is actually probably the easiest of these three, so we'll leave off with a not too tough one. Notice that in each of these logs, the base is 5. So if the base is the same in the logs, you can kind of just cancel them out. And then we can just say the stuff after each log is equal to each other. So in this case, 7x plus 1 is equal to 3x plus 13. And hey, we've been solving these equations for years, so let's just go ahead and get x by itself. So I'm going to go ahead and subtract 3x. These cancel. I get 4x plus 1 equals 13. I can subtract 1. These cancel. I get 4x equals 12. And if we divide by 4, these cancel. And x is 3. All right, so I appreciate you guys taking the time to watch that. Contact me if you've got any questions. Find me. We'll figure out what your questions are, and hopefully we'll do well on this quiz. All right, see you guys next time.